Hello, I'm MC Toon. Welcome to my channel. You know, I had a debate recently with Adam Meakin on the Israeli Flat Earth channel Esh News. It was a nice debate. Adam and I got along pretty well, and the moderator was pretty fair. I'm going to mirror it here. One thing I will do is I'm going to skip over a couple of the beginning parts. If you want to watch the whole debate, I suggest you do that. Go ahead. I'll put the link in the description, and I'll also put the link to Iron Realm Media, which is who Adam Meakin does podcasts and YouTube videos with. So right now, we'll jump right to the second question, where both Adam and I are answering the same question from the moderator.
Adam, can you explain what the size of the sun is, in your opinion? What is the composition of the materials from which it consists? What is its distance from Earth? Whether it is moving, and what is the speed? Adam, you can start.
No worries. I think first of all, size, speeds, etc., etc. What we have to realise is that all we have is angular sizes and angular speeds. And that leads basically to give us a proportionality from observation, which is how things work now. Fundamentally, the way in which we pin some numbers to this is assumption based, and that's based on the transit of Venus, where the assumption was that Venus is the same size of Earth, and therefore all the calculations are worked from that. And guess what? Modern science proves that, that random guess that Venus was the same size as Earth turned out to be true. So how lucky did he guess correctly?
So it's not surprising that Adam does not know things about the sun. But his ignorance is not all that there is to it. Many people, thousands of people, for many years have studied the sun and found out lots of things about it. We've measured the distance to it in more than one way, but apparently Adam is only familiar with one way that we measure the distance to the sun. He should maybe catch up with the times.
Well, I think I'd leave that there in terms of all of those. We can certainly define proportionality with regards to the observational data that we have, but anything else, nobody's took a tape measure out there.
Nobody's took a tape measure out there. Apparently Adam thinks that the only way to measure the distance to something is to bring a tape measure to it. Sorry, Adam, there's many ways to measure distance other than tape measure. Bouncing lasers or radar off of things, triangulation. In fact, triangulation is how pretty much all of our country and state borders have been measured out. Again, Adam, this is not new information. We can measure things more than just with a tape measure.
In terms of composition, I think what's important again is to look at modern science and how it would define it, because that's the best we've got. And in that, it's important to differentiate between real spectroscopy and the standards that it upholds, and celestial spectroscopy and what we're doing here to define the composition of these. In the case of the sun, 93 million miles away, apparently. So what they use is what's called an emission spectra. Now, most fundamentally, there was a number of contradictions with modern science. Most fundamentally is a gas can only emit a partial spectra. Sunlight is emitted and gives a full spectra. A gas, outside of being a ball of gas in space, which is a misnomer, how does it hold itself together? But say fundamentally, the sunlight we receive is a full emission spectra. Gases only emit partial spectra. Now, the assumption in which the way the composition of the sun is made up is based on, like I said, celestial spectroscopy. And there's a gap, basically, in the full spectra, and that corresponds to hydrogen and helium. The assumption is that this gap is caused by a slow-moving set of the compository gases which encompass the sun, and it's those that interfere, which are those primarily hydrogen and helium. Now, reality is that even in modern science will admit that hydrogen and helium could be anywhere between the observer and the sun. And what I would say, modern science does confirm that the top layer of the atmosphere consists mainly of hydrogen and helium. And we do not exclude this zone
8,
in
7.
our analysis. Okay, I'm finished.
So I'll get back to spectroscopy in a minute here because I included in my response during the debate. But in short, when Adam was asked about the size, composition, distance, and whether or not the sun is moving, he said nothing. He gave no information about it at all, basically. Now, the first question, which you go watch it and you can see, he basically had the same thing. He didn't have an answer to anything. This is the second question, and he doesn't have an answer to anything. So he's 0 for 2 so far.
Siren? Yeah, good. I just like hearing the sirens. It's amazing. We'll see it afterwards. Anyway, good. So we'll get to the second question for Michael. Do you want me to repeat the question, Michael?
No, it's the same question. That's good. I can go right into it.
Yes, you can start.
Okay, so I have a few different studies that I put on my website at mctoon.net/sun, S-U-N. And I'd like to first refer to one called Radar Echoes from the Sun, where they took a large antenna, and they actually sent, this is in 1959, they transmitted radar in a particular pattern of long and short pulses for 900 seconds, I think, just under the 1,000 seconds, I believe. That is the distance predicted by 93 million miles, the amount of time it would take. And they received back radar bounces. And so this confirms two things. First, that it is a physical object, and second, that it is approximately the distance that they were looking at that has otherwise been measured. Right, so that's one. It's a physical object. Second, and like you said, Adam, that they've used both the transit of Venus and Mercury, as well as the angles from the Sun and the angles from Mars to get its distance. So all these different methods to measure the distance are in good alignment with each other. They match well, and all of the more recent measurements refine that number and shrink the margin of error. So there is a study on my website there called the Astronomical Unit Determined by Radar Reflections from Venus. Now that doesn't necessarily require Venus to be the same size. It's about the distances. So, and then for the composition, there are, when you're looking at spectroscopy or Fraunhofer lines, you do see primarily it's hydrogen and helium. They do also have measured carbon, nitrogen, oxygen, potassium, magnesium, aluminum, silicon, and others, several others, by using these lines. Now those lines for these elements, we do not have, for example, a large amount of magnesium or tin or vanadium in our upper atmosphere. So there is an unknown thing that would cause between here and there these different Fraunhofer lines to be absorbed when you're looking at just our atmosphere and what's in between us and the sun.
So there's my response to what is the size, composition, and distance of to the sun. As you can see, my response had a lot of information. You can go look at some of those different things on my website at mctoon.net/sun. So to contrast, I gave a bunch of information, and Adam said, I don't know anything. I have no problem accepting that Adam doesn't know anything about the sun. All he has, though, is denial. Right? There's lots and lots of experiments and lots of measurements that have been done to find out the distance, size, composition to the sun, and he can only reject them. He doesn't have anything to present in their place as evidence supporting his belief for where the sun is, what the sun is made of, or anything like that.
All right, thank you very much. With 30 seconds left. Thank you very much, Michael. And with that being said, we will get on to the next part of this debate. And it will be a different question to each opponent. And we will start with you, Michael, on this one. All right?
Okay.
It's kind of a little bit of a long question, but yeah. The topic for both of you guys for the first question is visual proofs. Michael, early last month, December 5th, the SpaceX spacecraft CRS-19 mission takeoff was aired live. When the spacecraft reached the altitude of 162 kilometers, a rat was observed walking on the engine while the spacecraft was traveling at 10,879 kilometers per hour. These kinds of visuals, which, in my opinion, are at the very least unreasonable, are commonly revealed to us by footage from space, and strongly suggest that the moon landing footage from 1969 was filmed in a television studio. Can you scientifically explain these images, and what is your opinion of them?
So that rat was not a rat. So if you look, there's it looks like it's like that plastic silver blanket that you'd wear, you give to victims of disasters to keep warm. They have that coating over the body of the mechanism of the rocket engine, and on one side you can see that it's intact, and on the other side you can see it's torn. So that looks like it's a shredded piece of that just got caught up in the cowl around the rocket engine, and it's moving around there. Now, if it were a rat, it would have been blown off or something, and the movement of it is slight because there isn't very much air, so it doesn't move a whole lot. It eventually falls off, but it's pretty clear what that is, and I think saying that it's a rat is just seeing what you want to see, or what we say, pareidolia.
Oh, I love the rat thing. It's funny because it's so clearly not actually a rat. It's, what you might think it is. To say it's a rat is pretty ridiculous. There's many other things you could claim it is, but a rat doesn't make any sense. It's really funny though, because it's such a clear, an obvious example of them seeing so badly they just want it to be fake, that they'll see this thing that they think is a rat, and they just somebody plants that idea in their head and they accept it. They just take it and eat it up because they want it so badly to be fake. But it is, when you look at it pretty clearly, it's not. And there's two sides to the camera. There's one on each side of that rocket, and it flips back and forth. And if you look at the original footage, you can see that the one side is billowed out like it normally is, and the other side is a little deflated and flappy like that. And it's pretty clear that it's been damaged on the one side. Things like that happen. No big deal, and it's pretty silly. I think it's pretty fun though that he asked that, and fair question. And he was decent about it. And then he asked me one more question.
Yeah, and regarding the moon landing footage, have you seen anything which is commonly been claimed by flat earthers as a fake footage, as fake images? Can you elaborate on that one?
Yeah, I've seen quite a few. Like, for example, one where either Buzz or Neil is coming down the ladder, and you see the Earth in the background. That picture has actually been fabricated by somebody, maybe trying to cast doubt on the moon landings, because that actual picture of the Earth is from Apollo 8, what they call the Earthrise picture. It's not from Apollo 11. And when you look at there's no image of that on NASA's website. The only image we have is from third parties, and when you look at it, you can see the JPEG artifacts around the moon. Plus, being that it's from Apollo 8, it's a pretty obvious fake. Others I've seen.
Half a minute left. Yeah.
Yeah. Oh well. The flag. The flag waving is a pretty common one. And if it were in air, it wouldn't wave, because if it were it would stop waving because of air, not continue waving. So the fact that it actually continues waving tells us that it's in a very low pressure area.
Well, I thought that one was pretty fun because he basically just left it open, and I had to pick what things to debunk or address, and so I'm like, oh, there's so many, but that there's like these super easy ones that I are the most common ones that people fall for, and for him to say that he asked Muriel in the previous debate about it, and it was the same answer. Well, yeah, of course it's the same answer. The truth is the same every time you answer it. So it's of course expected to have the same answer every time. But super, that was pretty fun, pretty easy.
All right. So thank you very much. I will have to be honest. I asked in my previous debate. I asked the same question, Nuriel. He pretty much answered the same things. Kind of like was a little bit more expanded, but yeah, he pretty much answered the same things. All right, Adam. For your question. The sun setting over the horizon is to many visual proof of planet Earth's rotation. Can the sunset be explained using the flat Earth model as well? You can start.
I'm aware how the movement of lights in the sky is supposedly used to validate things. And this is, of course, in most cases, it's backwards, because the lights in the sky were moving before the invention of the ball. So fundamentally, any matching patterns, you're not going to build a model when you've already got the observations and not have the model match the observations. So fundamentally, statements that say, oh, well, it matches, don't actually prove anything. They're just a correlation. But what they do is pin the ball model to certain things which have to be adhered to, which is useful, in other analysis. These predefined things that, if we're going to attribute this rotation to this movement that we see in the sky to the rotation of us underneath, then that has consequences. So I've no problem with it, but I mean fundamentally there's nothing scientific about it, is what I would kind of say. So in terms of flat Earth and the term model, then no, we don't have a flat Earth model. We're just embarking on this journey, and to try and pin a model with the research and funding we have is a silly thing. What we do have is an understanding of perspective. We're developing understandings of how the atmosphere works and effects in the atmosphere. But for me, is it something like the ball is used, a fundamental underpinning of the concept? No. It's just they are, at the moment, certainly from a scientific point of view, just lights in the sky. And
40 minutes. Yeah, 40 seconds.
I was going to say, I can't go that long. And so for me, any inference that you would try to draw to them with regards to, in a ball position, the shape of the Earth, or for a globe, a flat Earth's position, the nature of what the Earth is, then I think it's foolhardy, because at best you're only ever going to get something that matches your model. You're never going to get anything scientific that you could state it as.
So let me remind you what the question was to Adam. It was, can you explain why the sun appears to set? And did he answer that for the flat Earth? Well, no. He basically said the sun is just a light in the sky. which requires him to completely ignore the evidence that I already presented, which we've covered. All that Adam has is denial. And then he says there's nothing scientific about it, and says that all we would have is matching a model, and that's not scientific. In fact, though, that is the very essence of science. In science, we build a model. It's part of the beginning part. We make observations, and we're going to build a hypothesis. But before we build a hypothesis, we need a model so that we can test the hypothesis. It's essential. And of course, as soon as you make a claim, which he's doing, that the earth is flat, you have a model. It's the beginning of a model. It's very rudimentary, but you have one. And so then what we need to do is find out, well, does this model make sense? Does it match observations? And he's not even willing to attempt to do that. He says we understand perspective. Perspective is easy. It's uniform shrinkage and angular size with increasing distance. Nothing magical about it. It can be calculated. He says we understand atmosphere. I don't think he does, but fine. He doesn't even address it. He completely skips over the answer. So that's 0 for 3 for Adam, completely deflecting on the answer.
All right, thank you, Adam. All right, and that concludes our third stage of this debate. And as I mentioned earlier, the fourth and the fifth questions are going to be presented by you guys to one another. We will begin with Michael's questions to Adam. Okay, so whenever you feel you're ready, Michael, you can ask your first question to Adam.
Okay, so there's some numbers. The specifics of the numbers aren't critically important, but if you want to look at them, they're on my website at mctoon.net/ashnews. That's ESHNEWS, no space or dash or anything. So here goes. Gravimeters are precise accelerometers with 9 to 12 digits of precision. They use a sealed, evacuated, temperature-controlled chamber to house the measurement device. They can be rented by anyone wishing to test for themselves. So the measured downward acceleration in Fairbanks, Alaska is 9.821981599 meters per second squared. And in Kauai, Hawaii, it's 9.787881888 meters per second squared. The law of gravitational attraction, which is F equals G times M1, M2 all over R squared, and Earth's centrifugal acceleration accurately predicts these values to less than 0.25% error. This is independent of the gravity of the density of the object. So what non-mass to mass attraction explanation has been confirmed experimentally or empirically to supplant the law of gravitational attraction with the same predictive accuracy?
Adam, have you understood the question?
Yeah,
you're good. Okay, so you can start.
The first question is which gravity, Newtonian or Einsteinian?
I'm just speaking about this measured downward acceleration.
Yeah. So you're implying this acceleration is it affected by a mysterious force which is created by mass attracting mass, as in the Newtonian sense, or is it created by the bending of space-time and is not a force?
Okay, so I'm sorry, my question is, at the end, is what has been confirmed experimentally or empirically to supplant the law of gravitation with the same predictive accuracy? So it's not about the law of gravitational attraction. It is, what is your explanation for this downward acceleration?
Well, yeah, primarily. So my first point is we're analysing the device. You're saying gravimeter. That implies, first of all, that it's analysing gravity, but unfortunately, I think even in your introduction to it, you actually correctly define what it is, and that's an acceleration measuring device. And what happens is we then pre-assume and apply this gravity term to it. It's not measuring gravity, is it? It's measuring acceleration.
Right. This is your final answer, Adam?
Well, yeah, a gravimeter is not a gravimeter. In its own definition, like I said, it measures acceleration fields, which I think in Wiki they say something like it's which can sometimes be referred to as gravity field. Well, it's not. So we're being scientific here. So let's discuss what we're measuring, and let's not exceed the boundaries of what we can apply the meaning to. And certainly, if we're going to apply it to something, this is where my first point was, are we applying it to us being able to measure the bending of a conceptual medium, i.e. space-time, or are we applying it as that we're measuring a mystical force where mass attracts mass? And I think if you're going to evaluate a device, understanding what it's measuring is crucial.
Yeah, so the measurement is a downward acceleration. And if you are not accepting mass attracting mass, my question then is, what is it that is the cause, in your opinion, and that has been empirically and experimentally verified, of this downward acceleration? So it's not about gravity, it's about not gravity. What is your not gravity explanation for this?
I don't need a just so story, do I, to point out that your just so story, that the reason there's a variance in acceleration has nothing to do with you renaming the device a gravity meter. That doesn't mean you're measuring gravity. It doesn't mean you can apply it.
I'm not assuming that. I'm asking for your explanation for it.
Well, I said I don't provide an alternative just so story. That would be non-scientific. What we can do is scientifically analyze
a hypothesis.
All right. I think, Michael, that Adam's answer was pretty much clear for what he thinks. I think that we can move on to the next question.
So I knew the format for this debate before it happened, and so I carefully constructed both of the questions that I got to ask to Adam, because I wasn't actually supposed to have a response immediately to him, though he kind of changed that up and asked me the question back. But asking that question, I didn't expect an answer from Adam, because there is no answer. There is no flat Earth explanation for the downward acceleration. They want to reject gravity, but they won't step forward and put together what they think is causing it. And I don't envy their position. It's impossible. There is nothing. But you notice he didn't attempt, as I knew he wouldn't, he didn't attempt to answer the question. Instead, he immediately went right to the semantics of what is gravity, and showing that he doesn't even understand what gravity is claimed to be, and the name of the gravimeter being grav in it, instead of just saying it's an accelerometer, and trying to answer the question. So it was perfect. His answer was absolutely perfect, pure deflection. And then the bonus is he claimed, he said, I don't provide an explanation. It's non-scientific. That's the opposite of science. Science is about exploring our natural world and finding out what's going on. Science is definitely interested in providing an explanation for it. And he's not, because he can't.
Michael, you can present your second question.
Oh, all right.
Okay. Is Michael going again?
Yeah, he's going again, and then you're going to present your two questions.
Okay. No worries.
Okay, so and I'll put this also on my website here. So on the same site, if you want to read it along or refer to it, when measured using a proper solar filter, the sun's angular size varies from 3.5 arc minutes to 31.5 arc minutes to 32.5 arc minutes everywhere on Earth over the course of a year. This matches the measured distance to the sun, as I previously referenced, and the ellipticity of the Earth's orbit. If the sun is not this measured distance in size, how is its narrowly ranging angular size explained?
All right, Adam, you can start.
Yeah, I think I'd probably concisely refer you to what I said earlier. Only a fool would try and purport a model that didn't match observation. So, of course, it matches. The observations were first, the model second. To try and claim that that your numbers match when you built your numbers from the observations and your numbers match the observations is false, isn't it?
So I'm sorry, you're
stating,
still.
it's
sorry, Michael,
don't
interrupt. Yes.
It's a statement of the obvious. Of course, it matches. I would not expect the Bohr model to not match. Why would that be a validation? Where would the initial numbers have come from? From observation, and then, yeah, that's why we have to have a bit of tilt. We have to have a bit of this to explain how in the model, their model, it has to be to match the observations. So I don't see any validity within stating that the numbers match.
All right. That's the end of the answer.
So after he had his fourth deflection in a row, he's 0 for 4, I asked the final question that I get to ask him about the sun's angular size. And no surprise, complete deflection. Again, no answer at all. He's 0 for 5. He didn't answer any question at all. It was pure deflection, every single one in a row. It's a good question, I think, because observations are observations, and so when you have a model, which he doesn't want to have, then you test the model against observation. If it matches, that gives validity to the model. He has no model, and he knows he can't do a model because nothing he will ever present will match observations. He's stuck. Flat Earth is stuck because there is nothing that explains the observations. It's just magic and faith. That's all they have. So he again tries to claim that not having a model is scientific. That's the opposite of science. I don't know what it is that he thinks is science. Maybe he should use a different name than science, because what he thinks is science is not science. It's something else. So, because science, people do science and they have to. Their jobs depend on it. He just gets to walk around and claim all this stuff about science, and there's no ramifications because nobody's holding him to meet the standards and actually produce anything of value, which is typical for flat earthers. They have no model, no evidence, no anything that works. Again, I don't envy their position, but thank you very much for coming up with 0 out of 5 answers. Now, Adam asks me 2 questions back.
Yeah.
Okay, good. Thank you very much, Adam. And we have plenty of time left, but I guess we'll use it to switch sides. And Adam, you can start presenting your question to Adam, to Michael, and go for it. First one.
Cool. Yes, I mean, it wasn't really. It was a more general question because I knew I'd be coming to talk to somebody from the ball side, so it wasn't so much to have the first one a challenge. It was more to understand a concept that's kind of going off in debates and that, which seems to be a position that's fallen back to. And so the question is why do a lot of, and I won't lump everybody in because not everybody has the same opinion, but why do a lot of ball earth proponents say that science doesn't prove anything? It's as simple as that, the question. And I think because I would include yourself in that, you've made that statement. So that's kind of why I wanted to ask that question. So it's not much a challenge, it's really an asking of an explanation for a theology.
When did Michael presented this statement, Michael? Adam?
And the quote I've got is on Jose J.G. Gonzalez's show, whilst debating Anthony Riley. Toon says, "I'm sorry, That's a little bit of word games. I will not accept science proves things, because scientists will stand up all day long and say, no, I'm sorry, we don't prove things.
All right, Michael, you can reply in your own time.
Yes. So I say that science doesn't prove things because that is what scientists say. It is something that you can't do in the physical realm. You can prove things mathematically, for example. There are math proofs, but there are not scientific proofs. The way the scientific process works is you test things, produce a hypothesis, and the hypothesis doesn't prove anything. It typically fails to disprove something, and by doing that, it gives supporting evidence to what it is that you're looking to explore, right? So when you have a large number of tests that you've done and experiments that you've done that have produced supporting evidence in something, then you start to gain confidence in the accuracy of it. And at that point, then it's called a scientific theory. A theory is not a hunch. It's not a guess. A theory is a concise description of many things that together work and have a predictive model. You can use it to make predictions. So, and that's kind of opposite the common parlance word for theory, where people often use it in place of hypothesis, where they mean a guess or a hunch or something. So, nowhere in the scientific literature or philosophy of science do you find people saying that science proves things. And I'd refer to a very nice website written by the University of Berkeley. If you just search for Berkeley, what is science, or Berkeley understanding science, you'll find it. And they specifically go and talk about whether or not science proves things. And they say, no, we don't prove things. We can sort of disprove things.
1 minute.
But even that isn't its science strength. It finds evidences for things, and when you have lots of evidence, then you have a high level of confidence.
And here we are back at Adam's misunderstanding of science and his definition of it that is not actually what is science. We really need to think of a name for it other than science. But he like thinks that I'm like the one that is making this claim, and he actually called my assertion that scientists don't prove things a theology. That's very strange. Science is not a theology. It's not a faith-based thing. It is a evidence-based thing. So it's very telling that he says that, and I know where he's getting it from. Scientists definitely don't, in general, say that they're trying to prove things. Sometimes people use words in common parlance. They'll say theory when they really mean hypothesis, and even scientists will do that. And same thing with saying prove when really the pedantic term would be provide lots of supporting evidence. So you sometimes will see that in literature that's maybe written in a non-specific, non-technical way, but when scientists are speaking about the philosophy of science, they're very particular in saying, no, we do not prove things. So I have on my website at mctoon.net/proof a list of different publications and quotes from different people, scientists and people writing about science, that talks about science not proving things. So go ahead and have a look at that, and including the Berkeley one, which is a fantastic overview of science written at a college level, which is maybe a little too high for most flat earthers. I don't know. Certainly some of the Nathan Oakley and QE people, that will be over their head. But everybody else that finished high school should be able to read that just fine. And Adam, being a pharmacist, I think that he can probably would really benefit from reading some things on what is science, other than being educated from it by people that don't know science, people that are not scientists. So
All right. Thank you for your answer, Michael. And we will go forward to the next question of Adam, which will actually be the final question of this debate. Go ahead, Adam.
Excuse me. Yeah, nice simple one to finish one. A flat earther's favourite, I suppose, for you. So, how do you have gas pressure without a container?
Oh, that's easy. Gravity. So the second law of thermodynamics does not state anywhere that there is a container. In fact, it talks about the distribution of energy, and we know through E equals mc squared that energy and mass are interchangeable. So it's a distribution of mass and energy. So what will happen is it seeks its lowest entropy form. So if there's a force pulling things together, it will coalesce into a sphere. If there is no force involved, then things will distribute evenly throughout the area. So if the Earth did not have a downward acceleration, then we would expect to see according to the second law of thermodynamics, a uniform distribution of air pressure throughout the atmosphere. But we don't. We see a decreasing pressure with elevation. You can see that driving up a hill. You can have and feeling your ears pop. You can put a balloon on top of a bottle doing that, or you can watch the most recent video from Dwayne Kellum, who had a barometer on his 120,000 foot balloon. Now he is, to my understanding, a flat earther. So the Dwayne Kellum I See Stars number 24 would be his video that has the barometer. So we see a differential in the pressure, and the second law of thermodynamics states that if there is no force causing a differential, then we would expect to see an even distribution, but we don't. So the question is, what is the cause of this disequilibrium? And I say gravity. And nobody else has presented any other explanation that I've seen yet for that force causing the disequilibrium. I've seen people say it's a dynamic system, but never an explanation for that dynamic system, because when we have a differential of pressure that great, we see huge fast rushes of air switching places to equalize it out. And we don't see that in the atmosphere. It's very calm at the top of a mountain at times, and instead of having a great rushing of air coming up to meet it. So I think that the second law of thermodynamics definitely points to gravity.
Well, I was pretty sure that he was going to ask me that question. It is seemingly the most popular question right now, and flat earthers think that they have something on us on that, but they don't. Actually, it's quite the opposite. It is absolute death to flat Earth because of that pressure gradient, and they have zero explanation for it. What they do is they try to deflect from the pressure gradient and say, well, what causes pressure in the first place? You need a container. You don't need a container. You need something containing it, but you don't need a container. The downward acceleration that we measure, whether it's mass attracting mass or something else, that downward acceleration is the explanation for what is causing the pressure at the surface of the Earth, and the reduction in that pressure as you go higher in elevation is because it's near the Earth. All of the air is compressed near the Earth, and less of it is compressed up higher. And it never does go to a vacuum. That's a complete straw man. There is no vacuum. Now, Adam was at least polite enough to not use that straw man. There's no pure, perfect vacuum in existence. But if you use the term vacuum to mean a lower pressure, but still a positive pressure, then yeah, the vacuum of space does exist. It's arbitrary. It's been defined at 50 miles. It's been defined as 100 kilometers. It's been defined as the elevation at which lift-based flight can no longer occur. But what is the vacuum of space? It's whatever pressure it is in space. And in space is some distance up there. Don't know. Doesn't matter, because something is causing that compression, very obviously causing that gradient. It is the downward acceleration, for which Adam has no answer, and I did, perfectly explaining it using mass attracting mass. So thank you again for that opportunity, Adam, to completely discredit the idea of flat Earth, because again, you have nothing to explain the observations.
All right. Thank you very much, Michael, and thank you very much, both of you guys. It's been a lovely debate and good, serious questions, and happy to hold it. So for the final part of this debate, I will let you go back a little bit for your opponent's answers and see if you want to remark something about it. Adam, let's start with you. Have you got something that you want to reply to any of Michael's answers?
I think I'd probably stay away from the topics directly. So as a more summative thing, what I've kind of noticed is certainly from a validation point of view to take our standpoints, it's interesting that we have a lot of probability correlations that validate the ball Earth, things that we as flat earthers, took as read when we were on the other side, and on this journey we've investigated, and they turned out to be, like I say, a lot of it tends to be not the science that it was first painted to us as. But what I would say in terms of the gas pressure, gravimeters, a lot of the things we've discussed is, certainly from my point of view, the validation from my standpoint is the opposition that science, that validated science has with some of the claims for the Pole Earth model. That's the underpinning thing for me, is my knowledge and trust in science, as it does prove things, as scientists do prove, and there are numerous citations, but I won't go too few. But what I will just say to you is, science has proved that water boils at 100 degrees at sea level at 1 atmosphere of pressure. Information is only caused by intelligent agents. Combustion as a result of oxidation reactions. Lack of vitamin C intake in humans results in scurvy. Knowledge with regards to quantum mechanics of the existence of the Witch path information collapses the wave function. The rapid motion of collision of molecules with the walls of a container causes gas pressure. It's the necessary antecedent. Magnetism is caused by the motion of electric charge. These are all things that science have proved. Thank you.
All right. Okay, Michael, maybe you want to refer to more specific questions or answers that Adam had throughout the debate?
Yeah, well, I of course, the two questions I asked knowing that there is no flat Earth answer for it, and I do appreciate Adam's complete deflection on that, admitting that flat Earth has no answer for those things. Specifically then, the list you just gave of things science has proven, the first one is the exception to the rule. Water boils at 100 degrees is actually the definition of 100 degrees, so it's not proven, it's the other way around. The rest of them are all theories that are well supported with facts. And scientists and the scientific process would say any one of those could potentially be upset with the introduction of new information. But because they are so well explored, it's very unlikely, and we have a high level of confidence in those things.
So Adam gave a little list of things that he thinks that science has proved. And the first one is my favorite. He says, scientists have proved that water boils at 100 degrees at 1 atmosphere pressure, which of course is the definition of 100 degrees Celsius, not the proving of that. He completely got that backwards, and it shows a complete lack of understanding of the science behind how they do units, how they define units. Now, that unit has been redefined a couple times, and in fact, just in May of 2019, they redefined Celsius again. The definition of it changed, but the actual measured values weren't really affected. So yeah, Adam, don't believe the flat earthers that tell you things. Look them up yourself. That wasn't proven, that was defined. The other things just again shows his lack of understanding of how science works, because those things were not proven. They are theories, which is a sequence of things that together has lots of supporting evidence. It's very, very unlikely that any of those things that he listed will be upturned or modified, but it's possible. It's always possible. And scientists are humble enough to say, we don't know everything. We did not prove anything. And it's about honesty, because there's always the possibility that something else is out there that we don't understand. So yeah, Adam, I'm sorry. That's not proven just because you say it is. Any one of the scientists that were involved in those different things and setting up our very certain ideas about it will probably come and tell you. A lot of them are maybe dead now, but they'd say, no, we didn't prove it. There's other things that it could have been.
The one thing you said, you don't have a model, and then you kind of hinted that it's not scientific. Of course, scientific and having a model are one and the same. You make an observation, and as part of that observation, you build a model. You may not specifically think about building a model, but that's what you're doing, because then you use that model to construct your hypothesis. So when you say the Earth is flat, you now have a model. It may not be well developed, but you have a model, and there's ramifications from that. So when you have a model, which you do, then what you want to do is find explanations for all observations and fit them into that same model, and so you can have hopefully one model that explains everything. We have that with the globe. We can predict the sunrise azimuth. We can predict the downward acceleration. We can predict the angular size of the sun and the moon. All these using the same model, and you have unfortunately nothing. And I understand that, because there is really not any evidence for flat Earth, so it's difficult. You're in a tough spot. So I appreciate that. That's all I have on that.
All right. So that's the main part of the debate. Denier, who's the host, he does ask he gives us an opportunity for a little extra question at the end. If you want to watch it, the link's in the description. I recommend you do that. I don't want to take all of Denier's video, and so go watch it. It's I don't know, it's kind of fun. It was personal questions and stuff, so it was nice. So this debate was pretty good. It was a little short, hosted by Denier, very nice on that. The format was maybe a little sterile, because we didn't really get a chance to do the, somebody presents some evidence, and then we have an opportunity to respond right away. It was pushed off till the end, and we didn't really have a lot of time set aside for that either. So I don't know, the format maybe could be a little bit updated, but it was good. It was short, which is kind of nice. It worked well to just have a little short one. Part of the shortness means that I didn't get a whole lot of bingo there, so too bad on that. I'll put a picture of that on my Discord server if you want to have a look. So anyway, thank you very much to Adam and Denier for a pleasant conversation, at least. And if you want to see the rest of it, go watch it. I will just point you to go watch the whole thing on Esh News. And with that, that's all I have for this video. Thank you very much. We'll see you next time.